All right, perfect. Hi guys. Welcome to the AI powered business live stream of Scalefree. And my name is Michael Olschimke. Let me just double check here something before we go. That should be fine. So my name is Michael Olschimke. I'm the CEO of Scalefree, and we're trying a new format essentially, and we want to talk about data and AI essentially. And today's live stream is really about AI powered business, and I want to talk about first of all, who am I and why I think I can say something about that. I realize it's a niche topic here to some extent, especially when you combine this with Data Vault. It's a growing niche. That's a cool thing, and I believe that some of the viewers here today will be in the niche as well. But so great. And it's not a topic for everybody's interest, but it's in our niche. I think it's interesting topics. So. Yeah, who am I? My name is Michael Olschimke. As I said, I'm the CEO of Scalefree. We do a lot of data-driven consulting business essentially. So we started out with Data Vault consulting. We extended our niche as well, so it's not just about Data Vault anymore. We also do AI a lot. We do CRM consulting a lot. To some extent, out of a necessity from clients, also because we had building the skills internally, and we just said, okay, let's go let's go for it essentially to hit the market with that. And so that's where we are. How did I get here where I am? I didn't start with Data Vault my career. I actually started with AI in my career. So back then at my university level essentially, when I did my master's at Santa Clara University in Silicon Valley, we essentially distribute neural networks and MPP clusters to classify unstructured data sets. That's my research back then. And then I started my consulting career, and then I stumbled over Dan Lindstedt, the inventor of Data Vault, went to a training. There's a longer story, I tried to get out of the training, but I got forced into it essentially. And then when I realized what Data Vault is, I jumped on that train, I jumped on that boat, and started working with Dan on Data Vault essentially, and not on the topic itself. So I didn't contribute that much on the Data Vault topic itself, but I helped him to push this into the market essentially. That's my contribution in that sense. So that's how it got started. And then later on, so some people knew what I was doing beforehand, before I met Dan essentially and started with Data Vault or working on Data Vault, and they knew that I was doing research and on artificial intelligence, and they asked me essentially, can you build part of this, or can you generate the raw Data Vault using AI? And back then, that's in 2013 or 14 or something, I didn't know, to be honest, because I was still learning Data Vault. I knew the AI stuff, but I was still learning the Data Vault. And so I didn't have a full answer. I didn't say no, but I didn't have a full answer. And that's when essentially I kept working. But a couple of years ago, somebody asked me the same question again, and then I started thinking about this. And I started generating essentially the raw Data Vault using AI. That's another business I started. That's FlowBI. That's essentially a Gen AI for the Data Vault essentially. Talk about that one as well today. So every session essentially I'm focusing on this mind map. My goal is to have a session every week. There might be some exceptions when I'm on vacation, for example, or some other reasons. I also get sometimes sick, but hopefully not too often. And so it's always two-sided here. We always talk about data, and we talk about AI. Data on the left, essentially on this mind map here, and AI on the right. And I just go through these topics that concern me for this week, where I dealt with this week, what happened to my career or to my work days over the last week or weeks. And then it's more casual, right? It's not the Data Vault Friday, which you find on our YouTube sessions, on our YouTube account. The Data Vault Friday is really one question, one answer more or less. Could be a bit longer, could be a bit shorter, but it's really a good setting for a good recording. This one is good for a live session. That's the goal here. More casual. You can ask questions. So if you have any questions, just send them here via your favorite platform. At the moment, we stream this on LinkedIn and YouTube, so you can join there either way. And both have the capability of sending in questions essentially, and I see them here on the screen, and I would pick them up if they're interesting. I just pick them up and answer them. Could be anything related to the content I'm showing at the moment. Could be related to Data Vault itself. If you have a Data Vault question, we can talk about it. The only time limit I have, at least, is I have to pick up the kids, at least the youngest kid, at 2:30 Central European Standard Time. That's the only limitation I have. and only today. So I try to get rid of this duty next week, but if not, then this might be the case sometimes. So there's a limit, but it gives us at least 3 hours roughly, which I don't want to consume. I don't want to consume your time, but let's see how many questions we have, right? And how many stuff I can talk about, essentially. We also have a guest, so I'm trying to have a guest every week, a live guest where we discuss some topics. Today there will be a guest where we discuss implementing Data Vault on Databricks from Scalefree, a consultant who essentially had a recent webinar, Ricardo. Ricardo had a recent webinar at Scalefree this week, discussing essentially implementation practices on Databricks. And so I want to talk about the webinar with him and on implementing Data Vault on Databricks for that matter. All right. So yeah, that's a setup essentially. So both sides, we just go through my mind map that came to my mind this week, and we discuss this essentially. Yeah, so the first topic I want to discuss, and I start on the left side, we have the guest after the second option, and then we go to the AI side essentially of the house. The first topic I want to discuss is essentially the Lakehouse architecture. I just came, let me just show it to you, and it should be interactive, so let me just get this link here. Okay. Get this thing rolling. Let me just move this. And so the first thing is, and often a question that often comes up is Data Vault feasible on Databricks? And that has two aspects in my opinion. One is really on the one is really on the side of the architecture. How would we transfer the Data Vault architecture into Databricks, into their way of modeling, for example, way of setting up the architecture? And then it's really about implementing it. There's some concern and some comments out there that you find often actually that Data Vault on Databricks makes no sense, doesn't work, or what else, because of joins, performance, column-based storage, all these reasons. But I can confirm you that it actually works, and we just have to know how to implement this, what are the assumptions we make to make it work, and so on, right? So that's the teaser essentially. Now, we had a good amount of discussions actually, and we use this format here to also show you some artifacts we produce at Scalefree. Scalefree is not just a consulting firm in my opinion, or at least that's how I personally wanted to have it set up. When I founded the company back then with Dan, our goal was to have a knowledge hub, let's call it, because it's also on the website. To have a knowledge hub of knowledge all about Data Vault, but also beyond that, right? So it should be more than just Data Vault. That's one thing, and that's how we founded the company. And so there's a good amount of work done where we share knowledge both internally. We have a lot of internal meetings, how we spread the knowledge about technology, Data Vault, data-driven application, and so on internally. I just came, and I posted something on LinkedIn. I just came from a town hall meeting, which is done once a month at Scalefree, where somebody presents a slide deck, a short slide deck on a certain topic. This time it was essentially on multi-active data, how we capture this, what are the options, how do we recognize multi-active data in your data set, and so on. So one topic essentially, and then we present this essentially. The group, it's a group of people, group of consultants internally who present this topic to the larger group, and then we discuss it, spot errors, fix those errors on the slides, and then upload this to an internal knowledge hub. And we have I've been to town hall meetings, Data Vault town hall meetings with up to 4 sessions in parallel. Well, 4 sessions, right, in this meeting. So they can take a bit longer, and then we discuss these topics and really use this for knowledge building across the consulting base essentially. So sometimes, especially for the younger guys, when they come in as new consultants, they have to learn a lot about Data Vault, just like anybody else in the industry sometimes, or in projects. And we use this for teaching the young guns, for example, but also the more experienced topics and so on. And I like to jump in as much as I can because it gives me a chance of making sure that the Data Vault concepts are applied properly. That's the basic idea. So I just came from one, but then we also have internal systems like our own. We have at the moment we have 2 wiki systems, an old one, a new one, and we're currently migrating the good content. So the good content essentially to a new wiki and cleaning up the old stuff and so on, right? So use it as a chance to clean up the old outdated knowledge and so on. And we use the wiki for documenting Data Vault knowledge, knowledge about internal business processes, how to set up a new client, how to set up a new project, and so on, right? Marketing processes and so on are all documented. So all kinds of knowledge that we spread internally. We have a drive where we share presentation slides that we can reuse and so on, right? A good amount of work that most good consulting firms should do if they focus on high quality consulting work, right? And then we also have a lot of work at Scalefree, or a lot of knowledge that we share with external parties, with you guys. And the idea of Scalefree is really to think about this. Data vault is a niche topic. That's what it is. I mean, I have to be honest with you, right? It's a niche. It's not interesting for everybody. My mom doesn't care, to be honest. Well, she does care about what I'm doing, but not about data vault, in all honesty. And there's a lot of people, and most probably the majority of people in the world, and even in our industry, doesn't really care about data vault. They care about all kinds of other stuff: CI/CD, DevOps. They care about databases, database tuning, all kinds of topics, right? So we're in a niche topic. That's what it is. But on the other hand, and there's also alternative approaches, right? So it's what it is, which is fine. But on the other hand, it's a growing niche, in my opinion, from my experience. It's a growing niche. That means that I'm meeting more and more people all the time who have never heard about Data Vault. And that's great. If I meet somebody who never heard about Data Vault, I know the niche is growing, right? That's a cool thing. Because I have a chance to explain what Data Vault is to them, how we use it, what's the advantage, what's the disadvantages, and so on. So I'm using this stream here for the same purpose. So we're trying to broaden up the topics here, to have more chances of explaining what we're doing, what's the work we're doing, right? And the idea now is that we want to expand the niche. We want to help people to better understand Data Vault, because then as the niche grows, we're growing as well. That's our business model. It's plain simple. And that's why we have a lot of free assets that we put on our website. For example, we have a knowledge hub here. Let me just find my cursor. We have a knowledge hub where we post a lot of assets. We have a blog, we have webinars. We do have expert sessions that we share. We have a free Data Vault handbook, for example. We publish so internally we have a solution base, like a knowledge base, where we discuss certain topics, essentially, what could go wrong and so on. And then we discuss essentially how to fix this, how to improve the situation. What do we do when something goes wrong? How do we fix this? And the idea now is that the solution base internally has a good number of solutions. Some of them are good, some of them are not as good as they could be, so we improve them over time. And the good ones we actually publish here. So when I just go here for the solutions, you find some of our better solutions, essentially. I don't want to say the baseline here, but that's the solutions here which are requested by many clients, which we send out all the time anyway for free. And then we said, okay, let's put them on the website so people can just download them, for example. So, and I would expect that more and more of the solutions will come in here. This is only a certain aspect of the solutions that we have, essentially. All right, so that's what I want to show you. And then other aspects, like we have a visual Visio stencil for Microsoft Visio for modeling the Data Vault, essentially, when you have to create a PowerPoint slide or some slide deck, or you want to write a book, for example, and you want to use some stencils to explain what a hub is, what a link is, what's the relationship between hubs and links. That's the visual Data Vault stencils, essentially. And so on. We have a community, online community, that we set up with a partner in Australia, Ignition Data, to essentially have a forum-style community where you can ask questions and seriously go for get answers essentially from the teams. We have a YouTube channel, which is not here on the screen at least. YouTube channel, let me just show it to you guys. Yeah, at Scalefree.com. That's where you find our YouTube, essentially, contents. Lots of webinar recordings, lots of Data Vault Fridays. So when you go for videos, you'll find all the recordings. I have a Friday session every Friday from my base here, and those recordings end up here as well. So that's also important for us. So it's really about spreading the knowledge, talking about Data Vault, explaining what it is, helping you guys to really better understand Data Vault, and growing your niche. That's the idea. That's what we're doing here all the time. And with that comes consulting. That's all secondary. That's the idea. All right. So let me just go back where I want to go back to blog article. Okay. So yeah, we have a lot of content actually on Databricks and data mesh, and and how we set up a data platform on a modern Databricks data medallion architecture, essentially. And I also had a a couple of talks, and I'll come back to the talks essentially. Yeah, no, sorry. So this essentially is a webinar recording, I believe, or blog. Let me just double check. No, it's a blog entry where we discuss essentially how we typically set up a data platform based on Data Vault. So you typically have something like a staging area on your data platform. Let's call it very briefly data platform. You have different layers: staging area or landing zone. You have the enterprise data warehouse layer and the information delivery layers. And then you have data consumption tools like dashboards, reporting tools, applications, and so on. You have the source systems feeding in the data. So that's a typical Data Vault architecture, the Data Vault 2.0 architecture or 2.1 architecture, how we set up the layers. And these layers actually translate very nicely to the medallion architecture by Databricks, where you have a bronze layer for the functional-oriented raw data as it comes from the sources, unmodified or nothing, just dump in the data into the data lake. We distinguish here in the staging area often between a landing zone and a staging area itself. So landing zone is just the one-to-one copy from the source system. We don't attach anything, just a one-to-one copy. And then in the staging area, we need certain attributes, certain technical attributes like load dates, subsequence values, record sources, also hash keys, hash diffs if possible at the point. We add them to the staging area in the data lake, so we can then load the deltas from the staging area into the core, into the enterprise data vault layer with the data vault design, with the raw data vault. That's the basic idea. So that's the staging area. I'm a big fan of trying to avoid the landing zone, attach the attributes, the technical attributes directly in the loading pattern for the incoming data sets, and then load the data directly into the staging tables with those technical attributes. But sometimes if you can't do that, then we introduce landing zone tables for this purpose, essentially. But I'm trying to avoid having the same data captured twice, only for a technical reason, and moving the data only for a technical reason, essentially. So I'm trying to avoid that. Just because on high volumes of data, you wanna be more efficient to capture this data. And then we have the enterprise data vault layer. That's where you have the raw data vault, where you have the business vault, essentially. That's where we break down the data into the fundamental components, hubs, or actually business keys, relationships, and descriptive data, and we capture them in hubs, links, and satellites. Hubs capture business keys, links capture relationships, and satellites capture descriptive data. And then we have the information delivery layers, where we have this enterprise data layer that translates very well or matches very well to the silver layer in the medallion architecture. And then we have the information delivery layer, where we have the star schemas, the information marts, where we deliver information, usable information, as star schemas with dimension and facts, snowflake schemas, flat and white structures, and so on, depending on what the user requirements are for the information delivery. And that translates to the gold level. So we have a direct mapping, actually, between the data vault architecture and the medallion architecture, for example. That's number one. So architecture-wise, it's all good. It's all in line, actually. So that's what we do a lot. And let me just go back to the 1 second here. Full screen. Oh, okay, whatever. So let me just go back to the where it went. Oh, there you go. So that's the first thing I want to discuss, and we also have discussions on this. I'm not going into the recordings. I'm just showing it to you. So let me just stop the recording. Oh, it's going fine. Okay. So we also have Data Vault Fridays, couple of Data Vault Fridays, where you find those discussions essentially. You find them essentially from the Knowledge Shop. There should be Data Vault Friday. That's where you get essentially a link to all of these recordings from Data Vault Friday. And there's a few Data Vault recordings, Data Vault Friday recordings, where we discuss essentially, for example, a lakehouse architecture, where you find this architecture that we just discussed again and again. To be honest, right? It matches very nicely. So we have different aspects, different ways how we look at this, essentially from a Data Vault perspective, how we match and map the Data Vault architecture to the Databricks architecture, for example, to the lakehouse architecture. So that's one thing. So so I'm not going into the recordings here. There's also, let me just show you one thing. I hope I find it quickly. Let me go to my LinkedIn here. I should close this one here. So let me find this because I just recently posted something here. Here, I believe. Yeah. So you see the same. I mean, other vendors like this one just came from a VaultSpeed meeting yesterday. We went in the morning. Tim Hoffman, Jürgen Dackwall, and me went in the early morning. Jumped on this. Had some meetings with VaultSpeed for some other reasons, and then they invited us for their VaultSpeed next release. I don't want to call it party, but release event. It also includes some party event part. And they also showed the typical architecture they set up for clients. And it is exactly what I just talked about, right? They have a bronze layer with staging data. Maybe it comes in batch data, in CDC data, but it's as it says here, it's a source schema. It's really driven by the source. That's the bronze layer here. Then they have a silver layer where they break down the data, the incoming data sets, into the individual components. Again, business keys, relationships, descriptive data, captured here on the screen in hub-string satellites. And then you have the gold layer. That's where you have your star schemas, your snowflake schemas, your fit and write structures, and so on. The information delivery models, essentially, what the user would like to have. 3NF models for logical data models, for example, industry models, and so on, right? That's all the gold layer. That's what you can use for reporting, for dashboarding, for ad hoc queries, and so on. So they follow the same principles here in that sense. There's nothing. It's what we do. But then there's also a concern: does it make sense to have Data Vault Databricks? And you find a lot of comments, and we also captured this in. Why is it open always here? Okay, must be security, whatever. Okay, so we find this also a lot on LinkedIn, where people discuss: does it make sense to have a Data Vault on Databricks? Because yes, we break down the incoming data sets and manage them in smaller entities, right? We have these hub-string satellites, and then yes, we have to later join them back in, right? We have to join these entities to come up with a dimension query with a dimension entity, to come up with a fact entity, and so on, right? So on these joins, they present a problem apparently, and I leave that for Ricardo, or for our discussion with Ricardo, to figure out why this is a problem essentially on Databricks and how do we solve this. So there's a couple of blog articles and articles where we discuss this. There's even one article, yes, but again you find these different layers here from the middle architecture in Databricks, and how we match this again in Data Vault essentially. So the same discussion again, right? So don't go into this detail again. Plenty of articles, plenty of videos that you find how this actually works, how we do it, and how it actually works from an architecture standpoint. That's my first aspect I want to discuss today, right? Again, if you have any questions, shoot them here on the use your platform of choice to ask your questions. I'm watching the chat. Let me just make sure I'm really watching the chat, not that I'm just talking about it. So yeah, if you have any questions, just send them in, and I'll pick them up if they're good, or if they fit my flow of talking, right? All right. So we do it all the time. It actually works. It's a one-to-one mapping, easy to be done essentially. Now, what about implementing? Because people are concerned about the joins, about the many joins, and apparently there's something different in Databricks, which is different to other database systems like Snowflake or Oracle or Synapse, Fabric, and so on, right? So what's the difference here? And that leads us to the next topic, to the implementation, essentially implementing Data Vault on Databricks. So yeah, the first thing is, yes, I mean you're not the first one trying to implement Data Vault on Databricks. We've done this before, and actually there's some older content out here. I mean, I don't want to say old, it's maybe a year old or something, which is still good enough. But we discussed this for years now, how to implement this. And there's even an article that we wrote. Let me just go back here. That's a coincidence. It's written with Jonas from VaultSpeed. We do also work with other vendors, right? So it's not just with VaultSpeed, but it's just that I came back from yesterday's meeting with them. So there is an article. We had a blog series, or we're currently writing a blog series on the Microsoft Tech Community, how to build a Data Vault 2.0, Data Vault 2 architecture data platform on the Azure platform. And it's not just this article. If you scroll all the way down, if you ever find one of these articles, you can Google those. You can search for Scalefree, Tech Community, Data Vault. You'll find these articles quite easily. But when you scroll down, there's a series title page, and that's what you want to check out. because it's a series. It's not just one article. There's a couple of articles. We started out with, there's a structure in here, right? So we love structures. The first article is also a good one, where we discuss what's the value of Data Vault. And if you ever have to sell Data Vault to somebody, don't use the term Data Vault to sell a Data Vault. That's the basic idea. Especially if you talk to higher ups, don't use the term Data Vault. Because if I buy a house, a house where I'm sitting in right now, if I buy a house, I don't care how the architect builds the house. If they use screws or nails, I don't care. What I care more about is are the features. How many windows do I have? How many doors? Is there a roof? Is there internet? That kind of stuff, right? It then would be quite important for me actually. So, but that's the more. So it's all about features. What's the location? Do you have a garden? And so on, right? We talk about features. I don't care, to be honest, how they set up the roof. I have no idea anyway, because I don't know how to do this, right? I'm not good in building houses. I mean, you should see. We did some part when we renovated. That's my family house here. When we renovated it, we removed a lot of stuff. So that's what I did, tearing down stuff and then leaving it for professionals to build the new stuff, right? So I should have really done this, but there's also always a gray area. So I went for the networking stuff. So I installed the networks because I also realized I wanted it differently than the electrical company wanted to provide it or offer it to us. So what we did essentially, we had in every room, we have two twisted pair cables, twisted pair connectors. We have fiber channel in many rooms, not every room, but many rooms essentially. And we distribute these, or we put these network cables and fiber channel cables into the walls essentially. Yeah, I mean the cables are good. That's not the point. But the wall plugs in the living room and in the main bedroom, in the master bedroom, they are really not in the best location, let's say. So I should have left this to professionals to at least put the wall plugs in the right place. But that's what it is. So maybe I click a picture, then you realize how bad it is. So that's what it is. So it's too late for fixing. Everybody's laughing about it, but that's what it is. So that's the thing, right? Because I have no freaking idea how to do this. I knew how to set up the network because I'm an IT guy and I knew how to set up networks, that kind of stuff. And I know how to set up the wall plug. But the simple location, I just forgot that when you look at the floor, they will add some more layers, right? So when I measure it, I forgot that part. So that's what it is. Because I have no idea, right? I'm not good at building the physical house. I'm good at the IT stuff, right? So, and manager, when they go for a data warehouse, they don't know and they don't care how you actually build this. They look for the features and what kind of features you can provide to them, right? And yeah, that's the basic idea. So, and they don't really care what kind of are using screws or nails to implement some parts. Who cares? As long as the features are there, as discussed, it's great. So the first article is really for the business users. And yes, while we use the term Data Vault, we use it on purpose because this is setting up a Data Vault series, essentially, right? An article series on Data Vault. So that's why we went for the term Data Vault. But remove that when you discuss an enterprise data platform with your clients, with your managers. That's what we want to do. Don't discuss Data Vault, discuss the house, essentially. Now, the cool thing is, this article contains a lot of a bit of history, yes, but then the major section is really about the value of Data Vault. What's the value you can take away with it? What's the value in your terms? What's the value of your data platform, right? Don't use Data Vault terms. And we discuss different values, what you can get out of it, essentially. Regarding integration of data sets, regarding processing of real-time data, semi-structured data, unstructured data, distribution of the platform, having some parts in the cloud, some parts on-premise, automation aspects, all this auditability, privacy, data security, and so on. All these different aspects, all different values, high-volume data sets, and so on. That's what we discuss here. And that should be your blueprint for selling a data vault. That's the first article. So that sets the stage. That defines what we want to achieve here. And then we essentially focus on architecture. I believe for the next 4 articles here are really focusing on the architecture. So we go from the business level now to the architecture level, and we discuss the base architecture, the real-time architecture on Azure, We discussed the Databricks architecture. I want to come back to this one here. The Databricks architecture on Azure and the data science architecture. That's the managed self-service BI architecture. If you know Data Vault, if you went to the training, then you know what managed service BI is. It's done for power users, but also for data scientists, and that's the idea of this article essentially. And then we go into the implementation. No, sorry, to the model first. We go to the modeling aspects. That's the next 1, 2, 3 articles. Yeah, the next 3 articles. So we discuss the baseline hub sync satellites essentially. What are those? We discuss some more advanced data models. We don't discuss all of them. We only discuss, I believe, non-historized data, non-historized links, and multi-active satellites. And then we also have one to show the reader a broader picture. We essentially discuss the how to model a full use case Microsoft CM data, Dynamics data, CM data from Dynamics. How to model this. We explain some of our modeling decisions. Why do we model it this way, and so on. There's also, if you're interested in this, I had a talk at TDWI a couple of years ago. How do we model Salesforce data in Data Vault? There's a presentation, there's a webinar. If you search for it in our knowledge hub, you should find something, modeling CRM data in Data Vault. Let me just show it, because we have time, right? So should be fine. Let's try. I'm not sure if it's published, to be honest, if it's on the website. Okay, probably not. Whatever. Should be published, but I'm not 100% sure, to be honest. Address data, no, it's not the one. No, let me just double check that. This could be published, I believe. We should be able to publish this, to be honest. We have different patterns, how we model essentially. How do we model, let's say, opportunities and contacts and leads and so on, party over contact, lead, account, and so on, right? How do we model invoices with their line items? Because I'm a big fan of, for an invoice, I use a non-historized link for the header. I use a hub for the invoice number, and then I have a depend chart link for the line items. And the invoice number is in between those 2 links. The non-historized link for the header information and the header data, header granularity, let's say, and the depend chart link for the line items. The invoice hub is in the middle, and then we have satellites capturing, or non-historized satellites capturing the actual header data, not just the granularity, or the line item data to some extent. So that's my opinion, the most efficient design. If your goal is to produce facts either on the invoice granularity or the invoice granularity or the line item granularity, depending on what you want to produce, that's the best design in my opinion, or from my experience. So that's what we discuss essentially in this slide deck. And I'll double check with Marcus. Marcus runs the CRM business, but also he's doing also EDW or data work at Scalefree. And I'll have to double check with him where the slide deck is, to be honest. I'll remember this one. Again, okay. So, okay, let's come back to the topic here. I do this on purpose to some extent to drift off, right? So to show you some stuff that we do. And because my thinking also goes back and forth all the time. That's what it is. So, yeah, check out this article. Check out the article series. Remember, there's a number of articles. There's one last article missing. That should be Jonas. That's a reminder to you. It should be here soon, hopefully. So, yeah, in this article we also discuss how we implement essentially data vault on Databricks. We talk about the architecture here. We again map the data vault layers on the different medallion layers in the Databricks architecture. But we also have some code here, but not much. A little bit here and there. That's fine. So that's one piece. That gets us there essentially. I mean, we did these projects, but publication-wise, it's development, right? That's what it is. Because you have the time to write up what I mean. You implement this, you learn a lot, right? While implementing, you sometimes try out stuff that works and doesn't work, and then you start publishing once you know what's going on. It's at least my take on this. I don't want to publish something when I'm figuring out what to do essentially. So. Yeah, so that's the Tech Community article series, which is I think it's a great series. It's like a little mini update to the book, to the building a scalable data warehouse with Data Vault 2.0 book, Data Vault with the Insight. That's the update for the Azure cloud, if you want. So yeah, I think it's good reading, and I hope it brings value to the readers. That's my opinion. And then there's also we had a recent webinar this week, and that's why we also added this to the session today. We had a recent discussion. Let me just add Ricardo to the call, actually. So I'm getting him here tonight. He's now in the waiting room here. So, but we had a discussion here, Ricardo had a webinar on how to implement essentially Data Vault and Databricks. And he had a lot of code in the webinar session. That's what I liked about it. So, but I wouldn't say I'm a tool expert. I'm more on the conceptual side. And I know how to implement Data Vault on different technologies. But I realized that we have better people at Scalefree who know better these different technologies that are out there these days. And so Ricardo is one of them. So let me just show the article first. And then we bring in Ricardo here. Let me just click here. I have to optimize this apparently, because the tab always comes up on my second screen. And that's a webinar that you can also find when you go for it. Data Vault and Databricks, does it make sense? When you search for that, you'll find this webinar session. That's where you find the recording. So you can essentially re-watch the recording from Ricardo and go through the details. I don't go into too much details. You find a lot on the blog article here as well. But the code is in the webinar sessions, in the slides. Let's bring in Ricardo here. 1 second. Okay. Okay, there you go. So Ricardo, 1 second. Where are you? All right. So you should be here, my guest.
Hi, Mike. Can you hear me?
We can hear you, but we don't
Nice.
hear you as a guest. No, 1 second. So I'm using this for the first time, right? So I have
No worries.
And I'm getting Ricardo in here. 1 second. So guest 1, configure. There you go. Perfect. That's Ricardo. So okay, 1 second. Interview. Sorry for that, guys. Ricardo asked me, should we do a dry run first? And I was like, let's wing it. Let's go for it. Okay, Ricardo. So for that, the little hiccup here, we will have some more of them in the worst case. But Ricardo. So talk about the webinar you had. So how did you come to the data topic? To the Databricks topic itself. Why is the concern for you essentially?
Yeah. So basically, the way that I came to that is because I was actually introduced by your article, and then I was also already doing some research on the Databricks area. And then, we saw that there's actually a lot of interest on the Data Vault implementation, especially on Databricks. And as you said, there are a lot of questions arising around this topic, if it actually makes sense. So we wanted to explore this more into detail. I think you also had a Data Vault Friday talking about this topic, which I think was a first step for me to getting into that topic. And I actually have been seeing some discussions online about this. And for example, some people really are questioning if it actually makes sense, since you can get very similar results with the implementation, for example, features like change data feed and maybe some delta live tables. Through that, you can derive right away some type 2, slowly changing dimensions, some fact tables, and a lot of people saying that maybe the whole implementation of Data Vault is not necessary. Also, Data Vault, as you know, can struggle with some normalized models, some tables. And you know that Data Vault is a highly normalized model, so it derives in a lot of tables, and with Spark, maybe distributed system, and this can be maybe representing some performance. But at the end of the day, I think that Data Vault is really more there than just providing us a reporting layer. I think Data Vault is really there to provide us this solid foundation that you said. That's the real value, the solid foundation that allows us to absorb any changes very easily. At the end, the business requirements will always change, and what want to achieve at the end of the day is to have this flexibility of absorbing all of that. And I've seen some examples of people how they implement delta live tables with the classic medallion architecture. And there is a question always arising for me: how do they manage more complexity, more sources coming in? Because you start creating more dependencies between the tables that, at the end of the day, can become very difficult to manage when they're being held very much upstream.
Yeah, in the
And I
end,
think that they're. I'm sorry, yeah.
yeah. So in the end, the data that we process on a, let's say, Snowflake database or on a Synapse database or on a Databricks database is still the same data, right? It's just the
Exactly.
same data. You're just selecting a certain technology. That's number one. So data is the same, and that means you have all the bad stuff in there: the dirty data, the missing data, the good data as well, right? The ugly data,
Yeah.
the different data types, and so on. And then the requirements are also the same. The business is not changing the requirements just because you're using a different platform here, right? So they still have the requirements of applying business rules to cleanse data, to transform currencies into a different currency, and so on. And then
Yes, exactly.
they want to use certain tools for different use cases. Let's say they want to do dashboarding or reporting use cases. They want to have some integration with business processes and so on. So that's all the same. It's just a different technology we use, and that can't explain why everything is bad now. That's number one.
Yeah.
So, and what Data Vault is really about is not Data Vault is not a pattern how to implement Data Vault or how to let's say break down or build a data platform on Snowflake. That's not what Data Vault is. Data Vault is a concept. How to deal with your data, how to apply business logic, how to turn it into something that business users can use. That's what Data Vault is. It's a concept. And which means that, in my opinion at least, if you're implementing Data Vault on a different technology, the way how we implement Data Vault might be different. And what I had was once a use case, which you find also on the blog again. We implemented Data Vault on a MongoDB, and MongoDB is not a relational database. It's a collection of JSON documents. It's multiple collections. So the Data Vault, we use the concepts of Data Vault, but we essentially the Data Vault looks completely different to a relational Data Vault, right? So, but the concepts are still the same. We just applied it differently because of different technology stacks, and that's, in my opinion, true for if you want to use Data Vault on a traditional database, on a cloud database, on Databricks, on Data Lake, or in an Excel sheet. Truly
Yeah.
believe, I've never tested this though, I truly believe you could build a Data Vault in Excel and in a spreadsheet process of your choice. Never tried it and never recommend it, but I truly believe that. That's what it is. Okay, so go
Yeah,
ahead.
you can
So
do it.
yeah,
Yeah, no problem. No, and actually, I think that when we talk about Datable implementations, as you said, this is just a concept that can be implemented anywhere because it always works because of the consistency and the methodology behind it. You can always get consistent results. So I really think that the main challenge of implementing Datable on any kind of platform, including Databricks, is really convincing the upper level management that maybe Databricks is the right thing to do. Because sometimes maybe the Datable implementation is maybe seen as unnecessary. Some people don't like having so many tables in their databases. Also, you need a lot of planning. Maybe you need to train your people. Maybe you need to also get external support because Datable as it is, it anyway requires people with experience to be implemented correctly. And sometimes all of these things can be seen as challenges that maybe deviate people from actually wanting to implement it. But yeah, I think that all of these things that maybe make you lose sight of what's the real value behind a Datable implementation.
so what would you say? What you need to consider when implementing Data Vault on Databricks, or what are typical challenges people face besides
So I would,
many joins that say,
yeah. So I first of all would say that you need to consider all the performance tuning. Of course, that's very important. I think that you might require some deeper expertise into what Spark SQL might be some different. Also, the Delta Lake, because since we work at a file level here and not at a table level, for example, compared to other databases, those are things that you need to consider. Also, the cost management and monitoring. Maybe it's not as straightforward as Snowflake with the Snowflake credits, where you have better cost management. And yeah, I think also other things like the delta time trial and the historization things that you might consider as alternative historization methods. Those are also things that you need to take in consideration when you're building Datable and Databricks. I think that you need to have a good knowledge on the tool to also have a good implementation of Datable.
yeah, there's two things that you said that I find interesting. One is the delta tables, because when we have a GDPR case, and in Europe we have this what is called general data or whatever. I mean, you have to deal with personal data, right? And general data protection, GDPR requirement, whatever. So okay, and the idea is that we have to essentially reduce personal data from our data sets when the consumer, the subject, essentially requests the right to be forgotten, essentially by the layers. And but that's a concept, right? How do we deal with this? And from a data perspective, the base concept for dealing with personal data is to separate the personal data from the non-personal data. Always separate them so we can deal with those independently from the other data. And this concept holds true no matter which technology you use, right? So from my perspective here, I would just split the satellite, having two satellites, one for the descriptive data, which is of personal nature or classified as personal, and one satellite for the attributes which are non-personal. So, but again, it adds joins. But that's how I would solve it from a conceptual perspective. Any comments on that one, or do you agree, or is there anything you want to add?
Yeah, from a standard point of view, yeah, in data implementation, that's the way that you handle with privacy and security issues. But I think that Databricks, interestingly, there are some other features that you can use to maybe make the model a bit more simpler. And that's, for example, the whole leveraging of the Unity catalog there, where maybe you can apply some tagging and some data masking columns, and through all these attributes containing PII information, PII attributes, and through that you can have a more robust model and more simple model, but at the same time you still have the whole visibility of all the columns that contain the sensitive information. And actually, since Databricks anyway offers this delta time travel where you can query previous versions, that could maybe put on risk some GDPR issues when you get a right to be forgotten request. But thanks to the vacuum command, you can delete data, set this retention period to 0 hours, and then you are completely eliminating the information related to that person. So I think those are advantages of also having data implementation on Databricks. And here you can really see how maybe combining the both of best worlds can lead you in this case to a more simple model, but anyway having a robust data governance.
Yeah, cool. So essentially you're adjusting the concept to the technology platform of the
exactly
to the capabilities of the technology you're using essentially. Yeah. Okay. So and then the typical challenge is the joins, I think the reason really is because of the storage format, because Delta tables are based on Parquet. Parquet files are column-based storage. Column-based storage is not good for join. That's what it is. So because for those who don't fully know, there's different aspects of how a database, but also data lake, stores data on disk. And it all started with the row-based storage, where we have essentially in an operational system, where let's say you have a CM system, you want to have you want to show all the details of your customer record on the screen at once. So the first name, the last name, the birth date, and so on, the lifetime values, and so on. So all these attributes should be displayed on the screen at once, and that's where the row-based storage comes in, where essentially a relation gets stored on a database page on a disk using database pages. So the page has a fixed size, let's say 8 kilobytes in SQL Server, or maybe anything between, I believe, 2 kilobytes and 128 kilobytes or 256 kilobytes in Oracle. And so that's a page essentially. And then in a row-based design, you store the whole row, the whole customer record inside this page, and you try to add as many records as possible to the page essentially. When the page is full, you create a new page and add new rows. And then, but the problem is when you want to find out let's say the average value, the average amount of your lifetime values of all the customers, you have to get data from disk, and you pull these records from disk, from the pages, page-wise. You can't say, well, give me only one column from the page. You have to get a full page, and it gives you a lot of overhead, lots of data you're not interested in essentially. And that's why we have column-based storage, where a page only contains the data of one column only. So if one page for first names, one for last names, one for lifetime values, and if the page runs full, you get additional pages only for first names, last names, and so on. And the idea is that column-based storage has the advantage when you aggregate, you only need to get data from, you only get pages for lifetime values from disk. There's no overhead anymore. So it's super fast to aggregate. But when you want to join, especially when you have a multi-column join, you have to get multiple pages for the join, essentially. And plus, when you apply business logic, typical business logic, at least in our space here, deals with multiple attributes at once. If the first is Ricardo, if he lives in Hanover, if he, what else, right? All these different aspects, and then we do something. And so applying business logic, but also joining is better. You're better off with a row-based storage, while for aggregations, you're better off with a column-based storage. And Parquet files are column-based storage, while, for example, the alternative would be Avro files. They're row-based. It's more, both are like they're hierarchical format for storing data, just like a JSON, which is text-based. Parquet files and Avro files are binary equivalents. But Avro files are row-based storage, and the Parquet files, they are column-based storage. And that's the deal. So the join performance drops down because of the column-based storage of these Delta files and the underlying Parquet files. That's why you have such a bad join performance, because that's true for every column-based storage, no matter which technology you use. Any insights how you deal with this typically?
Yeah, for example, in this case, when you were talking about a data implementation, you can handle maybe a lot of these more complex joins through some of the business vault objects that are very typical in data, like pits and bridge tables. You can use those to maybe pre-compute some of these joins, and usually in many projects you would implement them as views, but in the case when your performance maybe starts dropping too much, then you could already start thinking of implementing materialized views. That will, of course, help you to increase the performance. And then you can use these tables that are basically really in between the silver and gold layer in this case. So they're really, the case of the pit table is really a table that helps you to improve your query performance, and the bridge tables helps to maybe handle this many-to-many relationships and maybe make some range shifts. And with that, you are able to already get a boost in performance because you use them as intermediate objects that basically will allow you to create all of these information mart structures and in the information layer or in the golden layer, which in Databricks, because as you said, as it's columnar format, it will profit way more from maybe flat and wide structures as maybe a star schemas or some dimensional modeling. So we would want to maybe pre-compute many of these joins in these query assistant objects like pits and bridge tables and set, and then from there we can derive maybe some flat and wide structure, and also apply other techniques from Databricks, like also maybe optimize the files so we compress them into smaller files, putting them together. Also applying set ordering or liquid clustering, for example, where it creates basically a data layout where the data is better organized, and also thanks to the Delta Lake and this metadata layer information, Databricks creates these file statistics, for example, minimum and maximum ranges. So sometimes Databricks, when we make the partition on the right columns, where Databricks will be able to retrieve the right information, do some data skipping, and maybe skip all of those unnecessary files that we don't need, and then also all of that will have an increase in performance. So
I fully agree. So my take on this is quite similar. So think about this. And I had a CTO ask me once. They loaded all data into a data lake, and Databricks, for that matter, is also data lake technology in that sense. And they loaded all data into the data lake, and then he came back to me and asked me essentially, "What's next?" He's a friend, so he came back and he said, "Hey, Mike, you wrote a big data book. We just offload all data from the source system into a data lake, all nicely organized by source system. But what's next? What do our users want from me?" And I told him, well, users, they most probably don't want to have the source structures. They would like to have an information model to build reports on that, dashboards on that. So you have a target model you have to produce. And there's a gap in between, because on the left side, on the incoming side, on the staging area, you have all these functional source-oriented data sets where the model is driven by defined and driven by the source system. But on the information mart side, you have user requirements where the models are driven by the information requirements, what they want to report on and so on. That's gap number one. Plus the data gap, the content gap, where you have bad data, incomplete data sets in the incoming side, and they would like to apply certain business rules and so on the content. That's the gap you're looking at, and you have to fill this gap. Now, there's many ways how you can do that, but if you would indicate me all the business keys, all the relationships, and the descriptive data on your incoming data sets, we could then turn it into everything you want. Doesn't matter what you want, flat and wide structure and so on. So I'm starting to apply data vault concept here, but nobody said that you have to. I mean, you could think about virtualizing a data vault on top of these incoming files, for example. Longer story short, but in the end, data vault is just a tool to turn these incoming data sets into my target structures. It's just a tool. That's number one.
Exactly.
And then the performance of where's performance coming from? We have to distinguish between two types of performance: the loading performance, how fast can we load the data from the source all the way into the target, and the query performance. Those are two different aspects. So if your goal especially is to improve the query performance, I fully agree with you, Ricardo. I would challenge any join. Even in a dimensional model, I would challenge, why do we have fact entities and dimension entities in the star schema when we have to join them? Because a join on column-based storage is slow. Yes, there might be some exceptions when for example, when you have a large table in the center and smaller tables around it, like in this typical star schema, you have a large fact table in the center and dimension tables. As long as these dimension tables are relatively small, it might work, even on a column-based storage. But I wouldn't risk it. Why don't we just get rid of all these joins by having flat and white fact tables with denormalized attributes inside the facts? Yes, redundant data, but I promise you it will be fast, because the column-based storage is optimized for aggregations. There's no join involved. That's a performance killer. The aggregations on these fact tables will be fast. So that's my goal I want to produce. That's my opinion. That's what the goal we want to produce: flat and white tables, no joins, pre-joined or denormalized dimension attributes inside the facts. That's the fastest query you can get. And then data vault is just a tool to get there. And yes, we do break down the incoming data sets, and yes, we will have some performance issues when joining all that. But first of all, that all affects the loading performance only, not the query performance, because query performance we just optimize. So the only thing that's really affected by many joins in data vault design is the loading performance. And then we have multiple options. We can avoid certain satellite splits, for example. I would try to avoid any business-driven splits, for example. You can get away with, as you said, we have different technologies in Databricks, for example. How do we deal with personal data versus non-personal data with a private split? So we might avoid them. We might avoid security splits and so on. So try to avoid these splits to have less joins. And if that's not sufficient, well, then add just more nodes, and just add more nodes to compute these joins essentially. So it's just affecting the loading performance essentially.
Yeah, that's really cool how data will actually can also adapt to the technology where it's being implemented, and like there's how you make this combination. And as you said, you can make a more simple model, and of course it will be focused on the technology that you're having. But yeah, I think those are actually very good points, and I think that here you really highlight the value of the tool, as you said, of data. Well, it's just this tool that sits there to provide us at the end any structure that we want, because at the end that will depend on what the business users are wanting to see, and then from there we can really derive any structures. And the data, well, that's the cool thing. It always stays there as this groundstone basically that will move, and then from there we can always adapt to any incoming sources, any changing requirements, etc.
Yeah. Did you use any other tools for building the data vault on Databricks?
Actually, I was working for a while on the development of a package of the data vault for Coalesce.
Yeah.
And I was testing the Databricks environment. So I was working there for a while. And that's the tool that I've used so far. Besides that, I've also used just the standard Databricks notebooks there to make. Yeah, exactly.
Yeah, okay. And I saw your slides. So the code for loading the raw data vaults is essentially on the slides in the webinar recording, right?
Yeah. Exactly.
So if people are interested, if you want to find out, there's a link, which let me just show it to you again.
Yeah, actually, I was wondering if I should have included like in a file with the code, because it was pasted as image. Maybe I could have, I don't know if the marketing people could have attached something there, but it was something that I thought afterwards.
Yeah. No worries. We'll make it sure. So, but there's a recording you can check out. And that's where you find essentially. Let me just get Ricardo here. Sorry for that. That's where you find essentially the code you find in the slides. So that's a webinar recording. Go for it, and that's where you find the content of the slides. And is there any plan to implement the Databricks, the data vault patterns for Databricks in the DBT packages, or is it already in there, or
Sorry, what do you mean if
we have this data vault
DBT?
for DBT packages, right?
Yeah.
And Databricks is already supported, right?
Yes, it's already supported. It's already been released. Some colleagues have been working on that already. And yeah, actually, the Databricks adapter has been released a while ago for
Yeah. Okay.
DBT.
Cool. Yeah. And
Yeah,
that's also where you got the code from, or for your slides, or
yeah.
something.
It was generated. It's of course adapted.
Yeah.
Some Spark SQL function needed to be adjusted, but actually all the code was automatically generated by our package.
Yeah. Okay.
So it's
Cool.
really simple.
Yeah.
Mike, I only have maybe a couple more minutes because I have my next meeting at 12:45 and
Okay.
I need some
Okay.
minutes to grab some lunch. So
No worries.
no worries, we can go for a couple more minutes, but then I might need to leave.
No, that's fine. So yeah, I'm more or less done. So what's
Okay.
just last final question? What's your next step besides your lunch, essentially?
Actually, right now, as you know, I'm part of the research team here internally at Scalefree, and lately I've been researching on how to derive an AI feature store on Databricks from a raw data vault,
Yeah. Cool.
which is a complete new concept for me because I was actually always on the track of building information marts out of the raw data vault, and now will be a bit different on how to create an AI feature store for machine learning models. So yeah,
Yeah.
looking forward to it, honestly.
Okay, cool. Yeah, that leads actually me over to the next topics here. Let me just go to my mind map here, because we're more or less done with the. So thanks Ricardo for joining us today, or joining me here today, and
Thank
discussing
you,
data on
Mike.
Databricks. That's really cool. And yeah, enjoy your lunch. Thanks for joining, and hope to see
Thank
you
you
in
very
coming
much,
times.
Mike.
Okay, thank you,
Yeah.
man. Bye bye.
Bye bye.
Bye bye. So okay, so let me just double check. Okay, if you have any questions, right, just send them over. So yeah, that's the data side essentially. So good interesting topics. Again, we have lots of articles on the blog. We have lots of webinars. We have actual code. We have support of Databricks in the Data Vault for DBT package. So there's lots of content actually out at the scalefree.com site. And Ricardo had a good point. He's now working on the feature stores, or feature stores essentially for AI. That brings me to AI essentially. And that's the other side here of the today's live session. So I founded two companies, right? So I founded Scalefree in 2016, and that's really a consulting firm. We do big data consulting, data consulting, training, reviews, workshops, and so on. And then I also founded recently a company called FlowBI. That's essentially a Gen AI to derive a raw data vault based on input data only. So yeah, it's a data vault model essentially based on AI essentially. And again, it stems back to the idea or to the question: can you generate parts of the raw data vault using AI? That I received all the time, to be honest, in my career since I started with Data Vault. When people knew that I was doing research on data vault, on data mining, on distributed neural networks, on MEP clusters for the classification of unstructured data sets, people ask me this question all the time, but I never had an answer, to be honest, until a couple of years ago. I started thinking about this. I remember in one of the conferences, somebody asked me the question, gave me some ideas, and then it started my thinking process. I remember that on the flight back, it was an 8-hour, 9-hour flight, I was thinking about this all the time. That's one thing. So how could you generate this? And I knew the patterns in Data Vault. I knew good enough amount of data mining, at least to get a starting point. And then I started thinking about this. And that's where essentially eventually FlowBI was born. That's essentially, again, it's a cloud service where you can attach your data sources, and then it looks at your data. It's data driven. So it's not metadata driven. It's really data driven. It looks at your data and then derives all the hubs, the links, the satellites, that you need to, but including the business key selection, including the satellite splits, including everything, non-hysteric links, multi-active satellites, reference data, and so on, and that you need to capture your incoming data sets in a raw data vault. And it's not an assisting technology. My thinking process started with the fact, or with the idea, what if we turn around the whole idea? It's not an assisting technology. It's the AI takes over the lead, and we as humans, we assist the technology, right? Does it work or not? And that kicked off my thinking process essentially. And so FlowBI is such a technology. It takes over the lead, it makes the modeling decisions, but we can influence the system. That's number one. Now, the biggest concern we dealt with, and really once we had the MVP, we started discussing this with potential clients, and we're running POCs at the moment, and we're getting forward. It's typically lots of organizational issues that we face, but the biggest concern initially we got was that Flow BI as a cloud service looks at my own enterprise data, which is a challenge because there's everything in there, right? So that's a problem. So I looked at a lot of stuff regarding data security and governance for AI, local AIs, anonymous AIs, how to implement those, and so on. And then I realized, first of all, local AIs is really when you have a local AI model, like on a mobile phone, when you have the AI integrated in the phone, you don't have to send any data back when you let's say do voice recognition and give a command, and the applications on the mobile phone, the AI calls on the phone, and so on, and they produce the results, and there's no interaction except maybe some statistical analysis with the backend service, with the cloud service. It's all done on your phone. That's privacy-wise the best choice essentially. And then that's option number one. And then you have anonymous AI, where while data is sent back to the backend system, it's all anonymized. And actually, a lot of algorithms, even doing my research back in 2007 and 2009 at Santa Clara University, it was all possible already, right? So we had these options of let's say creating support vectors and only transmitting those for later processing to the backend system, for example, right? So there's different options how we can deal with this, where we don't need to share any data with the backend system. It's just as in some cases we separate the algorithm essentially, right? Support vector machines, you can do some work on the client and some other work on the backend system where you have more power, for example. That's all possible. And the support vectors, that's just a vector of numbers. That's it. There's no data in there. It's just indicating some direction of the vector in the space. That's it. So that's no data. It's just float values. And it's not turning your data into float values. It's just a float value that tells us for each document or each record where in the space of this three-dimensional or multi-dimensional space this document is. That's it. So that's not data. That's just a vector. It's really a arrow pointing to some place. That's it. And there's no way you can revert from a, let's say, support vector. I'm just taking this as an example, right? From a support vector back to the document. There's no way, right? It's just numbers, and it's not the document itself, right? So to be honest, I'm a specialist for text mining. That's why I'm talking about documents a lot. That's what it is. So it's all possible, and it was always possible to implement something like this. Just a quick one here, because I wanted to show you something personal as well, right? So I went to Santa Clara University. That's essentially a university in Silicon Valley. Let me just find if they have some pictures. In my opinion, if you look at this picture here, do we have a campus tour? Okay. So I have two aspects here. It looks nice. It looks like a vacation resort where I would go with my family and we chill, and there's a pool somewhere. There's a pool on campus for swim classes and competition and that kind of stuff. But it's not a place to chill, to be honest. For me, it was a lot of work. I took evening classes because the program at Santa Clara, I was in the business school, and they had two larger programs. One is the MSIS program, the Master of Science in Information Systems. That's where I went for. But it's part of the MBA program, more or less. It's at least side to side to the MBA program. There's some shared classes, shared professors, and so on. And Santa Clara is a relatively small university. It's not as large as Stanford or Berkeley, for example. It's a smaller choice. And they did this on purpose. So they said, okay, from their perspective, they don't want to become a large university. That's what they decided in 1800 or whatever. They on purpose decided to become a small university. And now they with the challenge that they have to essentially compete with the other universities in the area for the students. And their distinguishing factor was that while both Stanford and Berkeley had a at least back then. I'm not sure today, but back then they both had an MBA program, but the MBA program was a full-time program. So you had to quit your job to get into the MBA program at Stanford or Berkeley, and then you're done after a couple of years. You're done with the program, and then you go for a new position essentially. And Santa Clara said, let's do this in a night. Let's have this as a part-time program where you, as an employee inside the area, in the region, where you work all day, and then in the nights, starting at 6-7 p.m. or something, you join essentially the part-time program in the night, take classes until 8 p.m., 9 p.m., and then you head over back to work essentially. That's all it is. It's not every day. I mean, there were classes every day, but you as an employee, when you work in the area, you would then go for a essentially certain number of classes, depending on your work schedule, to make it fit in your family schedule and so on, right? Because you really work all day and then go directly to Santa Clara and work and visit classes until 9 p.m. or something, 9 p.m. and then you head home essentially completely wasted. That's what it is. I was full-time student because I had a scholarship for the university. That's another longer story by itself, but I received a Fulbright scholarship, and they paid for everything, at least for the first year, and I didn't have to work. The Fulbright program really pays you everything, which means that they pay you for the room, they pay for a bit of traffic. It wasn't enough to buy a car or something, but I was living close by, and they give you some money for survival essentially as well. So it's really full paid program, and so I didn't have the pressure to work one way or the other. So I did this full time, and I took as many classes as I could fit in my schedule, and to get this as quick as possible done, right? And so it was a nice campus, but because I took so many classes, it was a lot of work. So when I see this campus, I see me working in the lab, I see me taking classes, I see taking taking night classes all the time. So over the day I was doing research, and in the night I was doing taking classes essentially. So nice campus, yes, a nice location, very nice location. 300 days of sun every year. Here in Germany, where I live, here in northern Germany, I would say we have maybe 60 days of sun a year, like full sunny days, right? In a year, so quite a difference. But so it's really nice, and that's where I got my master's essentially. So it was part of the MBA program, and that's where we did the research essentially. And even back then, it was all about. I mean, the cloud was there in 2009. That's no doubt. But I was doing the research on my on MVP clusters we had in the school. There were some donations, and we essentially had an MVP cluster where we could run local models essentially. And I was developing these neural networks, and you find if you're really interested in this what we're doing here, or what I've done in the past. When you search for, fun fact, the algorithm was called DAN2. Yeah, this one. The algorithm was called DAN2. I mean, I have it with DANs. It was a dynamic artificial neural network, DANN, DAN2. That's essentially what we've done. So what I've done here is essentially we distributed before me. Everybody was doing or was implementing this neural network essentially on a local system. So they just used local systems. And in all honesty, most of these students were business students. Not all of them, but most of the students, I would say, came from the more business side. And they implemented the neural network in Excel, which I found an issue. I mean, I optimized the Excel sheet to the VBA macros for a while, but then I said, okay, let's skip this. And I started re-implementing this in R back then, especially because I knew that my data sets, I did research on text data sets, on like Reuters, for example, Reuters data sets, they were millions of documents, and you could not load this efficiently into Excel sheets, period. So I re-implemented this in R, and then I said, okay, what about all these cores, all these nodes in a cluster? Can we use them as well? Because I wanted to really process millions of documents. And then I started implementing this neural network in R against Open MPI and so on. So we distribute this against the cluster nodes essentially. And then so we distribute the code, we distribute the data sets, we let the distributed code run, and then we combined the data, collected the data from the individual nodes, combined them, and so on. So I knew how to build this, or I learned how to essentially build a distributed system for neural networks, essentially. That's the idea. And that's the paper that came out of my research. There's also that paper was published, actually not such a bad place, actually. And they and there's also a master thesis, which I didn't publish, and I wouldn't publish it that much. So, but that came out of it, essentially. And let me just go, where was I here? So let me just go back here. So, and back then we already dealt with local AI. I mean, this was a local algorithm we built. It was not running in the cloud, it was just on MVP classes. That's where we distributed this. And we had already the challenge of dealing with data anonymously, because we had cloud environments and there was a concern. But there was always ways to deal with this, right? You just had to know these algorithms, then you could implement something. But it wasn't a concern for me, so it was not my research topic, I would say. But when people came back to me and said, well, we would like to try out Flow BI, but we can't give you our data. That's not potential. The thing is this: we had the MVP for Flow BI, but the MVP, the minimum viable product, focused a certain niche, the niche where people wouldn't care, delivering the data into the cloud, right? And that's a very small niche. I can tell you from experience now. Very small niche of organizations would not care about this, giving you all the data or not. So most people cared. Most organizations cared about this. And then we said, okay, let's expand the solution in a way. Let's further develop a solution where we can expand the niche to capture more people, more organizations willing to test Flow BI, willing to use Flow BI, essentially, where Flow BI becomes a solution in their space to solve the problems. And then we looked at this again, but we also realized it's much easier for us. We didn't have to distribute the AI algorithms to span across different boundaries, which would be in our case for Flow BI would be a challenge. I mean, it would be quite a different design. But then we realized Flow BI has its name for a couple of reasons. One reason is Flow BI deals with data flows. Some people who went to my classes here at Scalefree, for example, they know that I'm looking at an enterprise data platform not as a model. I'm looking more into data flows. Data comes from essentially from a source, and it flows all the way downstream into the target, into your dashboard, or what else. And that's number one. So Flow BI deals with those data flows. It should integrate these data flows. That's number one. And we're using data vault capabilities for achieving that. Shared keys, shared business keys across the data sources and so on. And so that's number one. That's one reason why we call this Flow BI. Second reason was that there's also a back-end flow of how we essentially capture your data, analyze it, profile it, and then turn it slowly, step by step, turn it into a final model that we then deliver to our integration partners. For example, Data Builder or the Data for DBT packages by Scalefree, but also more partners coming up. I'm dealing with three active integrations at the moment, where they're building active integrations, and I'm having two more partners where I have to essentially get an update where they are. So we have more integrations to come. And this year, by the latest, we will capture 99% of the tools, or let's rephrase this, where we capture all the tools used in 99% of the projects out there. They use one of these tools that we partner with, essentially. So we hand over the logical model, or the hub sync settlers that you should use. We hand over to these automation tools, and then they generate the physical code. That's the basic idea. So there's a flow, and there's a certain set of activities that we follow step by step to get to this target. And there's a couple of more reasons, and one more reason is Flow BI was very short, so I love the idea of Flow BI as a URL of a domain code, essentially. Cool product name. Data flows was way too long, so I said Flow BI was shorter, so let's go for it. And okay, so that's the idea. And then design-wise, we go step by step, and we realize the first 3 steps of the whole process is essentially extracting the metadata from the sources, metadata, just the columns, the entities, the columns, data types, comments, foreign keys, all the metadata you have in your source system. Second step is the extraction of the data. into an internal data lake at Flow BI. And then the next step, the last step is, of the first three steps, sorry, the third step is then to do data profiling, where we create something like a fingerprint, let's say, of your data. You can imagine it's very similar to hashing, where you get data coming in, let's say a string, you hash it, and you have a hash value, a short value that essentially gives us an indicator of your data to some extent. We could use this for delta checks, for example, comparing hash values only, and I know is a change or not. And something similar we do as well. So we do something like a fingerprint. It's not a fingerprint. It's the result of the profiling. And this profiler is working on data. But after that's done, we only deal with metadata. That's what I realized when I looked at this challenge here. And I said, okay, well, then the most simple case is to distribute those three activities into the environment of the client, having a Docker image, for example, that runs against the data sources at the client on the client side in your AWS environment or Azure environment, and then only send metadata of the source systems, like the columns that you have, the tables you have, comments that you have, foreign keys, primary keys, all the metadata you have. We send this metadata back to Flow BI, and we send the result of the data profiling back to Flow BI. But it's also just metadata. I promise you there's no data in there at all. You can see this from the data volume. I'm happy to do an audit. There's no data at all that gets transmitted back to Flow BI. It's just metadata. Columns, table entities, and any names, comments, and so on. Float values, like vectors, that kind of stuff, but nothing more than that. Just the metadata, that's what gets transmitted back to Flow BI, and then we can execute the next steps based on the results from the profiling and from the metadata only. And that's what we realized. And that was or is still a large topic for me. I mean, it's implemented as a feature inside Flow BI, but we're optimizing the back channels and so on. So there's some also document. I mean, I did a lot of documentation, for example, last week on these what we call the local data. Here I'm at the moment, local data processing. How to set up the Docker image, where to get the container from, and so on. So that's what I'm, because I'm at Flow BI, I'm responsible for documentation. That's what it is. I didn't develop the Docker container. It's done by the development team, but I'm documenting it. That's my take on it. And then I said we're loading the data from the source systems of the client into a Flow BI internal data lake. Well, it's also a problem, right? We don't want to process the data. We don't want to store the data. Both aspects are important. So we also have a local data storage, and by local we mean here inside your environment, inside your AWS or Azure environment, or something else. At the moment we only support AWS and Azure. So instead of processing your data or storing your data, you can use those two options. And processing requires storage, and storage means that you can define your own S3 bucket or SQL pool on Azure, and we would use those essentially to store the data from your source systems, and then do the profiling on these local data stores with the local processing capability, with the local Docker image. So the Docker image runs against your local storage only, because there is no data anymore in our system. We don't store your data anymore. And then we send back the results from the profiling back to the Flow BI system, where then the AI takes over and does the rest essentially. And where we have an expert system and an AI and so on. And that's all done in the cloud. The user interface doesn't change, it's all in the cloud. But the backend system, in our case, the repository never stored any data. It's metadata only, and so that's it. So we don't see the data anymore. It's all gone. We don't see it, and we don't need that actually, because that's all done by the fingerprinter, by the data profiler, and then we're done with it. And the rest we can do with the fingerprints essentially, with the results from the profiling. So that was, I would say, a good amount of work for me last week, to document this, to do a lot of I don't want to say bug fixing, but like testing and issue tracking and so on, optimizing certain things. And that's the basic idea. I mean, we have some pictures here. I could show you something here for the data storage here. That's the architecture. 1 second. Oh, okay. Oh, fun. Here, there you go. So that's the architecture. We have the individual components here, and now with the local data storage, we can move the data lake, the S3 bucket or the SQL pool but also the query service, Athena or Synapse. We can move that into the cloud environment. So the yellow part here is on the Flow BI environment, and everything in white here, out of the yellow boundary here, is in the client environment essentially. So that's out of our scope already then. And then for the local data processing, we not only move the data storage out of our scope, we also move these first 3 steps, the data loader, meta loader, and data profiler out of our scope. That runs on your premises now, in your Docker containers. It's not one Docker container, I promise you, because this is an MPP cluster by itself. So you want to spin up a good amount of nodes, let's say, depending on how much data you have, how many source, what's your data shape and data volume. You want to spin up hundreds, tens, or thousands of nodes for a short while, not for days, only for minutes, but then it's done. And then we can essentially process the metadata in the following components in the data mining, model generation, in the expert system to generate the final model, and then we hand it over to the data automation tools like, again, Data Builder is a strategic partner at the moment, and then this is not at the moment, they're a strategic partner, and then we have Data for DBT, but we have 3 more actively working on it, and on the integration with Flow BI, and 2 more where I have to follow up. So that's the current state essentially. And with those tools, I would say that we capture most tools that are used in 99% of the projects out there in reality. That's the tools they use essentially. And then the game starts continuing essentially. All right. So that's a concern. So I did a lot of documentation essentially on the Flow BI platform. We have a documentation system where I describe this. Yeah, that's on the. There's some articles on the Flow BI blog. Let me just show it to you. 1 second. Oh, there we go. We call this initially Bring Your Own Bucket. It was a fancy name. We call it nowadays local data storage and local data processing. And that's where we describe this essentially, how it works, what's being transmitted and so on. How does it look like on Azure, on AWS and so on, right? What components do you need to set this up essentially? There's also a technical documentation for the POCs, for the project running at the moment. So that's just the front blog article essentially. All right, and then I had that was my work week, I would say, to some extent, besides the data part at Scalefree and so on. And then I had the pleasure. I got invited, or Scalefree got invited. Me and Jürgen and Tim Hoffmann, Jürgen Dagwald, Tim Hoffmann. We got invited to WorldSpeed's office. We had a meeting. That's one thing. So we had to discuss some topics. Let's say that. And they also had a release event. I shouldn't call it release party, even though it had some party components. So it was a release party where they showed some new features, and 2 features were the main features. One is the template studio, and the good thing is there's some blog art, some postings here. Let me just find. So you see these pictures here, right? And where is it? Let me go back to notifications. Oh boy. Yeah, okay. Can't find it quickly. But we have some, essentially some so I clicked pictures because I was ready in the meeting beforehand, before this release event, sorry. Because before the release event, they showed us the new feature already. So I knew what was coming. I had my camera ready and clicked some pictures. I posted them on my LinkedIn feed. The thing is, they just released, or they're releasing, let's say that. They're releasing a template studio, which is essentially a no-code environment for setting up templates. Like all these tools, these data automation tools, they have 2 major components. They have metadata that you have to set up either manually or using Flow BI that captures your, that essentially defines the raw data model, which hubs in satellites, business keys, satellites, and so on, do you need to capture your incoming datasets in a integrated enterprise model. That's the metadata part. And then you have templates, and what these tools do in very simple terms, they apply these templates to the metadata to generate your code. You create table statements for the hubs in satellites and your insert statements for loading those hubs in satellites from your staging area. That's the basic idea. And then they continue with the business vaults in some extent. And the data builder, VaultSpeed always had a feature where you could customize these templates, but it was text based. So they had some their own language, let's say, some it's called DSL, domain specific language, to set up these templates, when to apply what and what else, how to configure the create table statement, the insert statement, and so on. But it required some tech skills, right? You had to know the DSL, the domain specific language, the aspects, the grammar, the syntax. You had to understand the metadata from the system and so on to really build these templates. So there was a I would say there was a learning curve to learn these templating languages and apply it. And to ease that, they decided to have a no-code environment for that, because that's one of the aspects of VaultSpeed. They trying to get more, at least that's my understanding, they're trying to get more into this no-code environment, no-code space. And they said, okay, we must be able, or our users must be able to set up these templates without coding in a graphical way. So they came up with this template studio where you can essentially set up these templates graphically, right? And there's some pictures on my LinkedIn. Let me just find this quickly. Sorry for that. It should be here somewhere. Okay. Where's my posts? Show a post. There you go. Here, there you go. That's what I'm looking for. So let's see if we find this picture. Yeah, that's more or less the basic idea. It's a graphical user interface where you can do some ETL style, right? Way of setting up these templates essentially. Yeah, so that's the basic idea, and so that's a feature we saw before the meeting. So I knew what was coming, so I clicked pictures for today's session to some extent and posting on the blog. That was my goal, intention essentially, because I knew what was coming today with the live stream. And then they also showed something else, and I want to show you, and that's when I did a recording actually, because that was quite interesting. Let me show you the recording. And so once they had this template studio, they also realized, what about AI? Why can't we just generate these templates using AI? And I had always this, I had a couple of ideas in mind. One idea was to generate the raw data vault using FlowBI. That's one thing. That's where we don't use an LLM. But you can use an LLM, at least with my theory, you can use an LLM on the business vault side of things. And they picked up, we didn't talk about this, I believe, not sure, but they had at least the same idea, let's say that. And they said, okay, once they had this template studio, why don't we just generate these templates using LLMs? Why don't we have a text prompt up here? Let me just go full screen. Up here, you see a text prompt. I zoomed in a little bit later. You see a text prompt essentially where you describe some action and then some business rule essentially in plain English, and then it would generate you the business rule downstream. So let me just give it. It's a 2-minute video. Let's give it a listen here. Oh. And it should be. Okay, 1 second. Again, first timer here. This should be it. No. Okay, so now remember. So he's talking about this essentially, and they have the prompt up here. He clicked he went for it, and then the backend system essentially generates the template for this prompt essentially, based on the data you have from the inputs, comes up with a process. And then you have 2 buttons here. One is for accepting the business rule, the template essentially, and one for redoing it. So they didn't like what they saw, so they said, okay, let's give it another shot to get a better result essentially. Takes a couple seconds to generate. Couple seconds, not a couple of days to build this, right? Typically, you would ask a developer, hey, we got some data here. We have a business rule, transform. In this case, they do some. They convert some foreign currencies into leading currencies using some exchange rates on a given day. That's the business rule. That's what's written here essentially on the prompt. So you would give this to a developer, would take them a couple days to develop this, come back to you, present this, and you would also say, well, let's refactor this a bit and then you're done. A couple days and you're done essentially. Here it takes a couple seconds, less than a minute. So yeah, it's a bit of waiting state, but then should be there in a second. Bum, 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 bum. That was going on my head. Dum, 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 dum. They should introduce some waiting music actually, like on a call center. There you go. And then they said, okay, this is much better. This process here. And then they picked it up and modified it a bit. That's the last seconds essentially when they're done talking essentially. They modified a bit here and there to improve it, and then they were done with the template essentially. And here you see the final moments. That's where I zoom in. Yeah, you see the prompt here: retrieve the forex rate for the current date between euros and US dollars and use that to calculate the rental price of cars in dollars. All right, and that's the business rule. All came up from the LLM essentially. Applied to the template studio. They fixed there was some issue here with the join, I will remember, and then they fixed some other issues, little things here and there, and then they were done essentially. So yeah, that's for the business wall, right? The template studio opens up the technology here, Voltspeed, for more than just data vault, interestingly. So they could also produce other things like other models, whatever, right? 3NF models, whatever else. And on top of that, the LLM could produce business rules. In our terms, business vault Andys, right? This would be then turned into a business vault Andy and deployed into the business vault session. So that was quite interesting. Yeah, and now that's it's super cool essentially. I've seen this before in some cases, but not at this level. I've seen some experimental stuff, experimental work, some ideas floating around how to build this, and I saw this, but not at this scale or at this quality. I haven't seen this before, so that was really kind of a surprise. I liked it, so that was cool. So, but that's an upcoming feature. But I was allowed to share it. That's a cool thing. Okay, so that was essentially making my day to some extent, and this is essentially a picture from. There are a couple of reasons why they invited us. One was we had a meeting with them, so we said, okay, let's have an on-site meeting instead of a remote meeting, and then the release event, sorry, and after that release event, we had some little party with some foods and drinks essentially. And this picture is not the office. I mean, it's not the office here, but it's actually from the rooftop of the office, the surrounding area. And Volkswagen is located in Leuven in Belgium. So it was for our ride. Took us like 6 hours to get there. Well, Tim was driving, so it took us less than 4 hours. However he done it, at least on the German side of the road trip, we got it down to 3 hours, and then we had to slow down with the water. We had to slow down a bit, much actually, and then we went there by law with the different speed limits, and then we came to Leuven essentially, and the area where they're located, and I've been there before, so they relocated their office to another location, to bigger, better, whatever place, right? And but the same area, and the area is nice because that's actually a old industrial area where so Germans, I'm a German, right, natively, and Germans like what, driving and beer, not in combination though, right? So but we like beer as well, and I'm not saying I'm liking beer. Well, I do like beer as well, but this is actually from the Stella brewery. The old building. So they moved all the way to the left. I don't believe there's something you can see here. I'm not sure if there's maybe a building of the new complex, but I have the new complex on the left, and all these other buildings to the right. These are all the old buildings. Apparently, that's what they told us yesterday. The Stellar brewery, they moved from one location to the next and optimized the buildings, rebuilt the buildings, and so on. So they don't need the old buildings anymore. And then you have two options. You can either turn them down, take them down, and have a flat area and build something new, or you take these buildings and do something with it, essentially. And the city of Leuven, I believe, they decide to revamp these into office buildings, into apartments where you could live, where there's some student apartments and also very expensive apartments all mixed together and so on. And that's where we have startup centers in the area. You have retail stores. There's lots of cafes down there at the river by itself. It's not a river. It's a canal for the transport of the goods, of the beer, and also the ingredients of the beer, for the wheat and so on. And it's a nice area. You see the ships here, the boats. There's if you would look down the wall here, you would see a lot of cafes at the river, at the canal, and so it's a nice area, nice to work and live. There's startup centers, there's permanent offices where now Voltspeed went in essentially, and where they have much more space much more infrastructure capabilities and so on. And that's where we were at yesterday essentially. That's nice trip, and fast trip. So we went in and out in a full day. It was a long day. I was at midnight hitting home essentially. Cool. That's my stuff for today. So that's my topics. And we will repeat this here. I believe every week. There will be another one on Friday, next Friday, 11:30 Central European Standard Time, where we go same format. Have a different mind map, modified mind map, but data on the left, AI on the right, and we discuss topics that concerns me, and we'll see if people pick this up and like the idea, like the format. Make some comments if you like the topics, if you want to change something. It's the first. I mean, it's not unstructured, right? We have some structure here, and we can modify structure. If you have comments, ideas, make these comments on the platform here on LinkedIn or YouTube, for example, or send an email. Send us an email, and we'll take your input. That would be nice, and would be perfect. Cool. Then thanks for joining. I'm done. I go for lunch and then pick up my youngest kid from the kindergarten. Thank you guys. Thanks for joining, and see you hopefully next week. Thanks.